Hello, thank you for checking out Mr. Ware's videos. And today we're going to look at a lot of different problems relating with um, linear and exponential functions. We'll deal with some linear, we'll deal with some discrete and continuous, a lot of different things. It's going to be a two-part video. So let's just begin. So on this first example here, we got an element with mass of 420 grams that decays by 11.8% per minute. How much of the element is remaining after 16 minutes to the nearest tenth of a gram? So here I have my explicit exponential function here, and we're just going to plug in everything that we need. So I want to highlight everything that we need here. So first, the start, where we will begin with, aka the first term. We will need the common ratio, and we'll need the input. They give us the input on this one. So you see I got it color coded here, red, blue, and green. And I'm going to show you that in the problem. This right here, we begin with 420 grams. It decays by 11.8%. We're going to convert that into our common ratio. And our input, we want to know what happens at 16 minutes. Okay, so we got the start, the common ratio, and the input. Alright, so we're going to plug in those numbers. We're going to put 420 under the grams here for the start, and we're going to convert this decimal, or this percent, which is already a decimal, but it's a percentage. We got to convert it to a decimal. I'm moving it 2 places to the left. That'll make it 0.118, and we're going to subtract that from 1. Okay, and I'll tell you why in just a minute. And instead of putting X here, we're going to put 16 for the input. So that's 420 times 1 minus 0.118, close parentheses, raised to the 16. Now the reason we're using minus is because it's a decay. So since it's decaying, we're going to use minus here. Alright, once you do this, all you got to do now is just to type it into the calculator. So we're going to type 420 times, and you can put the times here or not, but 420, open parentheses, 1 minus 0.118, close parentheses, raised to the 16th power. Alright, and when you do that, you get a big decimal. We're going to round it to the 10th. So we're going to round this to the 10th, so it's 56.3. Alright, let's take a look at another one. Okay, the town has a population of 16,000 and grows at 4.5% every year. What would be the population after 8 years to the nearest whole number? Okay, same thing here. We've got the start, the common ratio, and the input. Those are the things that we need. Look and see if you can figure out what they are. Okay, so the start is going to be 16,000, the population. It grows at 4.5%. We're going to convert that to a common ratio. And the input is going to be, we want to know what it's going to be at 8 years. So we're going to plug those numbers in. We got 16,000. We're going to take that 4.5%, again, move it 2 decimal places. So that's going to be 0.045. And this time we're going to add. And then we raise it to the 8th power. All right, the reason we're adding is because it says grow. So since it's going up, we're going to add. $16,000, open parentheses. Okay, so the last thing to do is to put in the calculator. So what do we put in the calculator here? We got 16,000 times, open parentheses, 1 plus 0.045 close parentheses raised to the 8. Okay, once you do that, you're going to have this big number. Again, it may be a decimal, but because we're rounding to the nearest whole number, we're going to round this up. If it is 4 or less, leave it alone. If it's 5 or higher, round up. Let's take a look at another one. Okay, element with mass 330 grams decays by 25.5% per minute. How much of the element is remaining after 5 minutes to the nearest tenth of a gram? So again, we want to start off with, what are we going to start with? What's the common ratio and what's the input? See if you can figure that out again. Okay, we're going to have 330 as our start. 25.5% per minute is our common ratio. We're going to convert it. In 5 minutes, it's going to be our input. So we're going to write that in. We'll put 330 times open parentheses 1 minus 0.255. We took the 25, moved the decimal 2 places, right? Put it in front of the 2 and have 0.255. And this time, instead of adding, we're going to subtract because it decays. It goes down. Okay. And we're going to raise it to the 5th power because it's 5 minutes. Now all we have to do is type in the calculator. We got 330 times open parentheses 1 minus 0.255 close parentheses raised to the 5th power. Once we do that, we got 75.7. And since we rounded to the 10th, that's why we end up with this 0.7 on the end. All right, let's take a look at the next kind of problem. Okay, here, this is really similar. Here, we're going to write out the equations, and they give you multiple choice. So it's the same thing. We got the beginning, we got the common ratio, and we got the input. Okay, but what we have to do is write that out and figure out which one matches. So let's take a look at this first example. Benjamin has a collection of vintage action figures that is worth $340. If the collection appreciates at a rate of 10% per year, which equation represents the value of the collection after 6 years? So here's our input. Here's our common ratio that we're going to convert. And 6 years is going to be our input. Did I say 340 is the input? Sorry, 340 is the start. 340 is the start, common ratio, and 6 years for the input. So I'm going to write that out. I got 350. I convert this 10% to move the decimal 2 places, 0.1, right? And I'm adding it with 1 because it appreciates. And I'm raising it to 6 years. Again, I'm adding because it appreciates. But you can see it's not a choice here. Oh, I got 350. It should be 340. My bad. But it's 350. It should be 340. But as you can see, 340 is not a choice. Okay? So, what you want to do then is just go ahead and simplify this sum. So if you add this, I still put 350, but if you add this, you get 1.1. 1 plus 0.1 is 1.1, and that's right here. All right, let's take a look at another example. Okay, in a lab experiment, a population of 200 bacteria is able to triple every hour. Which equation matches the number of bacteria in the population after 2 hours? Okay, so we want to find out our starting point, our common ratio, and our input. So here we have the common point, 200. We have the common ratio, triple every hour. There's no percent on this one. It just triples every hour. So we're going to multiply by 3. That's the common ratio, 3. And 2 hours, that's going to be our input. So we're going to write that out. No need to add 1 or anything on this one. So I just got 200, which is where I began, times 3 raised to the 2. All right, and that option is right here at C. Now, sometimes it's a little funny. You see how they put like a lot of 3s here? This is too many 3s. But if they happen to not give you this option for C and give you this option, this is the same thing because it's 3 times 3 twice. So be aware of some problems like that. They might even do it with the growth when they give you multiple parentheses. So just be aware of that. All right, let's take a look at another option. No problem. Okay, a radioactive compound with mass of 390 grams decays at a rate of 29% per hour. Which equation represents how many grams of compound will remain after 8 hours? So what do we begin with? What's the common ratio? What's our input? So 390 is what we're going to begin with. 29%, we're going to convert that to our common ratio. And 8 hours is our input. Now, so here we're going to have 390, 1 minus 0.29 raised to the 8. And the reason we use minus is because it decays, it goes down. So we're going to subtract. Okay, and they try to trick you here. Look how they got that 1.29 here. Be aware. But that's not correct. This option is not here. And see, there's another one right here. You see how they have the right thing, but it's only multiplied twice? If they had it out here 8 times, it would work. Okay, but if you take the 1 and subtract 0.29 from it, you get 0.71. So it's 390 times 0.71 raised to the 8. So it's C. Okay, so run out of time here, so that's going to be it for part 1. Stay tuned for part 2, and I'm going to go over some more different things with some linear and exponential functions. But for now, thank you for checking out Mr. Ware's videos. Have a nice day.